Hello, my name is Michaela and I'm a biomedical engineer here with BTS Bioengineering. Welcome to our G-WALK webinar. Today I'm going to present the application of our motion sensing device, the G-WALK. For those who are not familiar with the G-WALK, it is a revolutionary, mobile, simple, and quick device that provides objective data that's required to analyze the gait pattern, timed up and go test, 6-minute walking test, turn test, running, and jumping. In particular, we will discuss the instrumented timed up and go test, which is used to characterize the functional mobility in elderly people. In this context, why is it important to evaluate functional ability? In recent years, there has been an increase in life expectancy, which has resulted in global aging population. In 2050, there will be an estimated 88.5 million individuals aged 65 or older in the United States alone. This is a 120% increase over the elderly population from 2010. Aging is characterized by progressive loss of motor skills, which leads to greater difficulty in maintaining balance and loss of fluidity of movement. These are key factors in the reduction of daily independence. In fact, after the age of 60, there is a significant decrease in the reaction time while maintaining balance, which leads to a decreased capacity of performing common daily tasks such as eating, cooking, and self-care. Moreover, the fall incidence in daily life and the severity of complications increases. For this reason, rehabilitation practices and healthcare professionals need to focus on reducing adverse effects such as bone fracture in elderly people while increasing their quality of life as much as possible. In this context, evaluation of elderly patients' functional mobility is fundamental. By assessing the degree of mobility, it is possible to define appropriate rehabilitative programs, therapeutic programs, and preventative measures, such as informing caregivers about the risks and home safety tools that they can use. How can we assess the mobility of patients? We can use clinical tests such as the timed up and go test. The timed up and go test is a test that is used to measure the total time a subject takes to stand up from a chair, walk 3 meters, perform a 180-degree rotation, and return to the initial position. This test consists of an action commonly performed in the daily life exemplified by turning, standing up, and sitting down. For this reason, functional mobility in elderly is often used to estimate fall risk and evaluates dynamic balance, walk, and transitions from sitting to standing. This test can be performed with a stopwatch, which is the common approach over the past years, or an instrumented way, such as using an inertial sensor, like the G-WALK. Over time, the number of publications about instrumented time up and go have dramatically increased, and the procedure in the clinical field has gained popularity. While the stopwatch is inexpensive, it only provides partial data and especially does not provide information on the test subphases, which are essential to characterize the patient behavior. Moreover, as it is not an instrumental measure, the acquired data is dependent on the operator time reaction and user errors. The timed up and go test can be performed in an instrumented way. Today we'll see how it's possible to use the timed up and go test with the G-WALK. The G-WALK is a digital tool that, applied during the timed up and go test, provides objective data in a quick and easy way necessary to analyze the patient's functional ability. Furthermore, the G-WALK is validated by the scientific community. The G-WALK provides complete data, objective data, and reliable data. The timed up and go test provides information useful to verify which aspects specifically of motor function are degenerating. In addition, in a recent study, researchers found that all of the timed up and go test parameters are negatively associated with grip force. Our G-WALK system allows one to obtain all this information in a very fast and easy way. So let's perform a practical session to see how easy it is to use the device. I'm now going to switch to our G Studio software, which consists of a patient database here, a record of the tests performed on a patient in the past, and a list of the potential tests that you can use to assess a patient. In this case, we'll be using the timed up and go test. To perform a test, you simply have to enable the device and connect the device. In this case, that's already happened. And we've also already connected the device to our patient. So to begin the test, we just simply have to select the correct test, and we can click the start button which will immediately start the stabilization phase. This is a quick phase in which the patient needs to stay still. And once this is complete, the patient can go ahead and start the test. The timed up and go test. Once they've finished, we can stop acquiring with the stop button and click OK and save. As you can see, the report is automatically generated. We will go through the analysis of the report and return to the presentation now. So this is the general layout of the report, and it's divided into subphases. Okay, great. Okay, I'll now explain the different parts of the report. And the first section is the timed up and go test and subphase times. In particular, we have the test duration, which is the total time spent to perform the timed up and go test. The functional mobility index, which is the mobility index of elderly in communities with different types of medical conditions. This is an index that is used and based on test duration that represents level of subject's independence, and is coming from an article which compares the timed up and go test and the activities of daily living scale, or the ADL scale. And then we also have the fall risk index, which is based on cutoff thresholds of the timed up and go total time described in the literature for different pathologies. To characterize this information in a more precise way, it's necessary to evaluate these subphases. As mentioned previously, in the timed up and go test is divided up into 6 subphases. Each subphase is representative of a common daily task and can be considered as a standalone test. By analyzing each subphase, it's possible to evaluate which task is more difficult for the examined subject, and thus they can inform appropriate treatments or preventative measures aimed at minimizing adverse events. For example, patients suffering from Parkinson's disease often have trouble turning. In the next part of the report, we have information on the sit-to-stand and stand-to-sit accelerations. By comparing accelerations during the standing and sitting phases, it is possible to understand if these are carried out in a controlled manner. It's important to understand that if the subject falls in the chair in the sitting phase, because this is a commonly difficult action for elderly patients and can be assessed by comparing the sit-to-stand and stand-to-sit phases. In the next part of the report, we have information on the analysis of turning velocity. In detail, by comparing the rotational velocity of different trials of the same subject, it is possible to analyze the subject's capacity to turn faster or slower during the change of direction of the 180 degrees mid-rotation and before sitting in the final rotation. In the next part of the report, we have information on the trunk angles by evaluating flexions and extensions during the sit-to-stand and stand-to-sit transitions. The flexion range represents the angle range from the beginning of the flexion to that of the extension movement. The extension range represents the angular range from the beginning of the extension to the end of the standing movement. In conclusion, the timed up and go test with the G-WALK allows for the objective quantification of a patient's motor capacity and provides useful parameters. Our system helps save time because the report is immediately and automatically generated and increases the quality of your assessment without changing daily processes, adding staff, or dedicating environments. Thanks for your attention. If anyone has any questions, you can type them in the chat and we'd be happy to answer them.